Hello everyone, welcome back to another video. This is the second lesson of Algebra 2. So last video we covered linear functions. We learned about the three main equations plus finding m and b values in linear equations. So now for lesson 2 we need to cover the second major function, which is exponential functions. So let's go and dive into that. So similar to the similar to linear functions, we're gonna first go over what an exponential function is. So I'm gonna write down exponential. So all right, here we go. So this is first main definition first. So exponential function is a curved line that increases or decreases faster and faster based on the value of b with a constant. So unlike it being a constant slope, this is an exponential function is a constant ratio. So you add, you multiply or divide by the same number. So what that means is that it's more about powers and stuff like that. So we'll get into that stuff soon. So also can be defined as a line that increases larger and larger after every x point. So it kind of jumps up, but it jumps up in a special way where I'll show you guys an example right now. To first understand an exponential function, we need to know the equation. So good thing is that there's only one equation for it. There's one equation for an exponential function, and I'm going to do f of x. So f of x, same thing as y equals. So f of x equals a times b to the power of x. So this is the equation to an exponential function, and there's two main ways this can be formatted. So there's two. So alright, so the first one is growth, so exponential growth, which that's the most common one, but there is also exponential decay. So let's start off with growth. So in growth, b is greater than or equal to 1, and it goes faster and faster. So for example, if we had, let's do 2 to the power of x. So we have, let's do an x and y table. So when x equals 0, as you know, if something is to the power of 0, that equals 1. So the y would be 1. And then 2 to 1 is 2. So 1, 2. Because the x is the exponent. This right here is the x. So if we do 2 squared, that's 4. So 2, 4. And now kind of like this, since the a value is 2, you multiply this by 2s every time. So this can be 3, 8, 4, 16, 5, 32. Alright, so that was kind of weird. Alright, so now let's move on to decay. So decay is the opposite, as you know, the decay is the opposite of exponential growth. But the thing is that in an exponential function, y is always greater than 0. because 0 is something called the vertical asymptote, which means is that it gets closer and closer to 0, but it infinitely never hits zeros. And most calculators, because of how the decimals extend like really high, they never show how it works. And so yeah, like I'll give an example. So pretend this right here is the x axis. An exponential function will gradually rise like that and will never hit 0. And same with decay. If we pretend that's the x, it goes higher and higher, but it never hits 0. So in decay, b is in between 0 and 1. So b has to be a decimal. So as an example, we're going to do, for b, we're going to do, let's do 1/2 to the x power. So we're going to go back to that x and y chart again. And the reason why I'm not showing a right now is because just like how b in in a linear function is the y-intercept, a is the y-intercept. So a is the y-intercept and b is the factor for an exponential function. So let's go back to this. So let's make the a, let's have, for this example, let's have a equal 4. So it's 4 times 1/2 to the x power. And since it's between 0 and 1, it's an exponential decay function, which would look like this. So we're going to start off as 0, which would be 4, because that's the y-intercept. And now, since we're multiplying it by 1/2, it's going to be 1, 2, 2, 1, 3, 0.5, 4, 0.25, and so on. So exponential functions are really weird, but that's how they work. So the a is the y-intercept and the b is the factor. So usually the y always multiplies it by itself, which is why I call it's exponential, because it goes either exponential growth or decay. So yeah, they're really interesting functions. They're pretty complicated actually, but we're gonna go and we're gonna give ourselves a data set example. All right, now we're on a blank canvas, so I'm gonna give myself a data set for an exponential function. So we're gonna do xy. So if I'm learning a new function, I like to compare it to basic linear functions. So we have a linear function right here, and we're going to use our knowledge from last time. We're going to do m equals y2 minus y1 over x2 minus x1. So we're going to do that. We're going to take 2 points. So we're going to do, let's do 12 and 315. So we're going to go and let's plug that in to m, to this formula. So we're going to do m equals 15 minus 12 divided by 3 minus 2. So that's going to give us 3 over 1, which equals 3. So the m is 3. And now we're going to do point slope form like last time, which is y minus y1 equals m times x minus x1. So let's go and do this. So we're going to do this 9. So we're going to do y minus 9 equals 3 times x minus 1. So we're going to distribute that. So we have y minus 9 equals 3 x minus 3, add 9. So the product is y equals 3x plus 6. And you can also tell because it gives us the point right here, which is the y-intercept. So I didn't really have to do point slope form. I just realized that. But that's good practice, I guess. Yeah, that's good practice. All right. Now we're going to move on to the second data set. So as you can see, you can also kind of find a rate of change because this adds 3, adds 3. That's another way to find m. So that also helps when you're given a data table, and that's what we're going to do here. That's how we're going to find it. So we're going to look at this. So 4 divided by 1 is 4. So this is multiplied by 4. So, and 4 to 16. 16 divided by 4 is 4. So this is multiplied by 4. 64 divided by 16 is 4. So that's 4. 256, 4, so on. So that means that b equals 4. And now in order to find the a, like I said earlier, a is the y-intercept. So we look at here, 0, 1. So a is 1. So the equation for this is y equals 1 times parentheses 4 to the x power. So you could kind of see the difference between linear and exponential functions. So at the rate of change through linear functions adds on a certain number at a constant rate, but exponential functions add on a rate of change through a factor of multiplying, or it could also be division or multiplying by a decimal when it's decay, but this is obviously growth. So I'm going to go and kind of demonstrate what these equations may look like. Alright, so we have, I'm going to show the linear. So I'd say we could put 6 there. Y equals 3x plus 6. So we'd have it like that. Simple. But then for the exponential function, as you can see, we start at 1, and then we go to 4, and then 16, and so on. So kind of goes like this. It rises, and it goes up and up and up, like that. So that's like the difference between linear and exponential functions, and you're going to notice it the same way with quadratics. It kind of grows with the curve, which is what makes it really weird. So I'm gonna give you guys about 20 seconds to figure out which data set is exponential. And yes, so I'll give you guys 20 seconds. All right. Yep. Time is up. So we're going to go over each one by one. And the main way to do this is by looking at the way it changes. So here we go by +1. Let's see here. +3. Here is +5. And this is 7. So as you can see, this is clearly not an exponential function. This is actually a quadratic function, but we will learn that next lesson later on. So not right now, so don't worry about that. All right, now let's look at this second function, this data set. So we're gonna go, it goes 1 to 2. So that's +1, or for here we're gonna do ×2. This is ×2. ×2 and ×2, and over here we go -2 +0 +2 +4. Dead serious? I actually have no idea what this is. Yeah, I think the answer is right here. it's the second option. So yeah, if you got that right, that's good. If you don't, it's okay. We can keep going, maybe try reviewing or looking at some other tutorial. But let's keep going. And so this is mainly going to be data set, like data tables. So we're going to do x, y, 0, 2, 3, 4, 5, 6, 7, so this is a word problem. So 32 teams are participating in a basketball tournament. Only the winning teams in each round advance to the next round. So it's one team on another team. As shown in the table below. Now, try to find what do you think? Try to take a guess. What do you think the equation might be for this? I'm just going to give a reference. Maybe try to find the a and the b values. So it's a times b to the x power. So try to figure out what a and b might equal. I'll give you guys 15 seconds. Alright, time is up. Let's deal with this together. So first, let's find the a value. So for the answer, I'm going to put f of x equals... Alright, so the a is the... Oh my god, that was terrible. The a is the y-intercept. So let's look at where 0 is. So 0 is right here. Let's go down 32. So that means a equals 32. So let's plug that into our equation. So a times b. So 32 times. Alright, now we need to find out what the b value is. And in order to do that, we need to figure out the factor. So let's look at this through a multiplication standard. So 16 divided by 32. So it was multiplied by 1/2. See if it keeps going that pattern. 16 to 8, 1/2. 8 to 4, 1/2. 4 to 2, 1/2. 2 to 1, 1/2. So that means that b equals 1/2. So alright, so that means it's 1/2 to the x power. So that also means that this is exponential decay. And that if we were to graph this, it would most likely look like this. Alright. So I know this lesson was kind of short, but I just want to give like a straightforward, really quick summary because I kind of want to speed through Unit 1. So that was just like I just want to give some practice problems so you can understand what exponential functions are, so we can really get into the fun stuff towards the end of this unit with piecewise functions, even quadratics I enjoy. So yeah, thank you guys for watching. See you later, and see you all in the next video.